Hello everyone, Mr. Schultz here. Welcome to Integrated 1. We're going to be taking notes on 3-3, which the notes would be linearity and the continuity of graphs. So we're going to talk about discrete versus continuous. So with a discrete function, the points are not connected. This is like, how many marbles are you going to bring? I'm going to bring 1, 2, 3, 4, 5 marbles. Can you bring 4.5 marbles? No. So you can't have the numbers in between. For a continuous function, the points are connected and they form a line or curve. So neither discrete nor continuous. This would be where, some points are connected, but not all. Not everywhere. So here's a visual example of it. Here's the points, not connected. Here are the points. They're connected all the way through here. Here are the points. They're connected here, and then they're connected here, but not in between. All right, well, let's go on. So the domain, it's a set of individual points. So it's like, all right, we have -4, we have -1, we have 3, 4, and 7. And it's a set of individual values for the range as well. Not points, I should have said values for this one. Sorry. The points are a set of individual values. There we go. So the domain for this would be all real numbers. Because, it goes from here and it's going everywhere to the left. And right here, it's going to go everywhere to the right. So it's all real numbers decreasing or increasing or whatever. Now, the range for this would be one interval of real numbers. Now, it's dependent upon the domain because we have independent versus dependent. This one depends upon the domain. And for this last one, it varies. We can't figure out like every exact one, but it would vary. All right, let's go on. So, determined continuity. Books. The bargain book, this should be red because you don't need to write it all down. The Bargain Book Barn sells young adult novels on a sliding scale. That is, the more books you buy, the cheaper they are. Let f of x model the store's prices for given quantities. Is f of x discrete or continuous? Explain your reasoning. Okay. I would say the function f of x, that's the function, would be discrete because you can't buy partial amounts of books. Like, sure, one book is $1.50, 2 books are $2.90. You can't buy 1.5 books. That's not right. There's a set interval amount for, the books. So that's not going to work out. All right, let's go on. Determine continuity by using graphs. Determine f of x and g of x are continuous, discrete, or neither. All right, so let's look at A. A. The points form a continuous I wouldn't say line, I would say curve. Therefore, f of x, the function f of x, is continuous. Now b, g of x. G of x, the function g of x, is not continuous everywhere, but it is continuous at some parts. Therefore, it is neither discrete nor continuous. Now, I used to make sure you put nor, neither discrete nor continuous. All right, let's go on. Example 3. Apply discrete and continuous function. Detective, as a private investigator, Tia charges $25 per hour for any amount of time up to 8 hours, and then a flat rate of $250 per day. Use the graph to determine if the function that models the situation is discrete, continuous, or neither. So, I would say if we broke up the two parts of it, the first part is continuous because it's $25 per hour. So it'd be $25 per an hour and a half, or maybe 3.5 hours. It's any amount in between. But then after that, it's discrete. It's like, hey, it's $250 per day. Doesn't matter if you do part of a day, it's the full amount, full day. So looking at this, since we see that it is continuous and then discrete, that tells us that, hey, this graph is neither discrete nor continuous. The first part is continuous, and then after the 8 hours, it becomes discrete. So then it's not discrete or continuous once it goes from continuous to discrete. So yeah, it's done. All right, let's go on. So linear functions and linear equations. All right, so a linear function is a function that has a graph that is a line. Okay, well, linear, line R, line. It has it it has it in there. It says line. Now, a linear equation is used to describe said linear function. So if I said y is equal to 3x plus 5, remembering from middle school, that means that, hey, this hits at 5 and it goes up 3. For every 1, the slope is 3 and it's going up, and it hits at 5. That's pretty much what the linear equation is. It's like, hey, there's parts of here that tells us certain things that happens. All right, let's go on. So finally, a nonlinear function is going to be really easy. A function that cannot, a function whose points where the points do not form a line. Now I like using this one. F of x is equal to x squared. That looks like this. A parabola. I like parabolas. Put your hands in the air as if you don't care and say parabola. let's go on. So, example 4, linear and nonlinear functions. Determine whether f of x squared minus 2x squared plus 3x minus 5 is an equation for a linear or nonlinear function. So right now, a linear function looks like this: y equals m times x plus b. That means it has a slope, has an x and just an x, and it has, where does it hit the wall? All right, well, if I go 4x squared minus 2x squared, that's 2x squared plus 3x minus 5. Yeah, that's not this. That's not x. Y equals mx plus b. This would be, this is a, so I would type it out. It'd be like, all right, y equals 2x to the power of 2 plus 3x minus 5 is a nonlinear function because it cannot be put into y equals mx plus b form. It has to, in order for it to be a linear equation, it has to be put into y equals mx plus b form. Or another way of saying it is, hey, standard notation, ax plus by is equal to c. But I don't really like this one. I like the y equals mx plus b better. All right, example 5. Identify linear and nonlinear functions. Okay. Well, we've already done this one, so let's do it again. So 3x cubed minus x cubed, that would be 2x cubed plus 3x plus 6. Once again, this is a nonlinear function. This is a nonlinear function because it cannot be put into standard form or slope-intercept form. So y equals 2x to the power of 3 plus 3x plus 6 is a nonlinear function because it cannot be put into standard form or slope-intercept form. The ax plus by equals c is standard form. The y equals mx plus b is the slope-intercept form. It has slope and the intercept. All right, let's go on. Example 6. 2 more examples and we're done. All right, functions in table form. All right, so basically what we're going to do is we're going to figure out, what is the slope? Is it a linear function? So looking at this, I can see that it changes. Now I don't like doing every single one. So I like to jump from 0 to 1. So from 0 to 1 is 44. That's 1. That's 1. That's 1. So I know this is, if I add 40, if I go 1 for the time, then the height should always be 44 if it has the same slope. Now it might not. Let's see. 146 to 58. That's going to be, well, that is 14. And then 58 to 38. Hey, wait a second here. That's negative 20. So as I can see from here, this is not a linear function. I mean, looking through here, every input has exactly one output. So I can type this out. I mean, this, get out of here. This is a function because every input only has exactly one output. This is a nonlinear function because the slope is not constant. If it was, every 1 would be 44, or every 1 would be 14, or every 1 would be negative 20, but it's not. This actually produces more of a curve. All right, last one, everybody. Identify linear functions by graphing. So at the moment, I'm going to tell you, guys, you don't need to bother with this. However, we're going to show this. So we're going to go from here. Is this a linear function? So this is every one. So this is +1, +1, +1, +1, +1, +1. This will be a linear function if it has a constant rate of change. So it looks like it decreases by 1.5, and 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 it decreases by 1.5 each time. So the slope, since the table has a constant rate of change, this function, is a linear function. There we go. All right, guys. Thank you for bearing with me, and I'll see you guys in class. Bye.